are now going to talk about analysis. Some of my students, precisely Shirin and Prajakta, went to Pune railway station, and as it happened, they had to catch train on some platform, and they knew that it was going to come to the first platform. So they're standing there, and some announcements took place, and they were busy talking amongst each other as well. And actually, the announcement said that the train will arrive on the third platform. So the train arrived and it went away, and these guys were still talking. The exact problem is that the announcement was not heard. And this is a common problem as far as India is concerned. Previously, in my younger days, airports did not have this problem. But now, airports also have similar problem. They are quite crowded. As far as India is concerned, they are thoroughly crowded. So we are going to talk about acoustic intelligibility analysis under such noisy conditions. There are a lot of public address systems. If I walk around over here, if I see the canteen, in the canteen, if I have to do some announcement, a lot of times it will not be heard, even heard or understood. Something happened and people will keep on neglecting. This happens on Bombay local platform multiple number of times. So with this experience, Shirin and her friend Prajakta decided that they will do an analysis. What is intelligibility, what is understood and what is not understood, and why. So basically a public address system announces something, and then there is an intelligibility, that is people understand the announcement or they don't understand the announcement. So first we have to qualify what is intelligibility and where does intelligibility come from. The first issue that we looked for was this intelligibility primarily lies in the consonants that those are being spoken. There are a lot of exercises on the internet as well, in which we keep on sending mails to each other, and we look at only the consonants. If you really see, the consonants primarily give a phonetic meaning, and vowels identify the person. This is what has been established. So now we look at that consonants to be heard in a particular situation. What does it comprise? So what is a psychoacoustic model? How does person understand? So in a psychoacoustic model, what we really see is, there are a lot of issues in psychoacoustic model. The relevant to this particular thing is, one is the level. That is, we every time feel that the level or the volume is the key issue, but it need not be. For example, somebody talked about music just now. So in the music background there is something playing, and in spite of that you are able to listen to the song part of it. The key issue also is not just the volume, but the key issue also is the frequency. Frequency is the tone or a pitch. The pitch separation also sometimes is important in intelligibility. In fact, the consonants part of it, from where we understand a particular word, has certain frequency spectrum or tone spectrum. This particular aspect gives us the intelligibility. The consonants give the intelligibility, and consonants have a high frequency content. So exactly we conducted this particular analysis onto the noisy condition and not noisy condition or less noisy condition. So we went to the railway station, we recorded the noises over there, then we did the announcements in a room, then we mixed these two and listened to it. Then we did certain analysis. I'll talk about the analysis after we have listened to what happens on the railway station. So to start with, for the first one is a male announcer. Male is saying something. To start with, what is being said, that you will listen to first with a less noise in a female announcer, then a male announcer, then with lot of noise, female announcer and a male announcer. This will be the four things will be played, and it is around 45 seconds each. So let's listen to.
Further, it is difficult to comprehend consonants and the noisy environment. For example, the difference between word and heard is very small. The identification of consonants involves correctly distinguishing the higher frequency components in a pronounced word. The human sound production and recognition system, the vocal cord and the ear, is less sensitive in the higher frequency area as compared to the lower frequency area. The corruption by noise in the higher frequency area makes the recognition further difficult. It is difficult to comprehend consonants under noisy environment. For example, the difference between word and heard is very small. The identification of consonants involves correctly distinguishing the higher frequency components in a pronounced word. The human sound production and recognition system, the vocal cord and the ear is less sensitive in the higher frequency area as compared to the low frequency area. The corruption by noise in the higher frequency area makes the recognition further. It is difficult to comprehend consonants and the noisy environment. For example, the difference between word and heard is very small. The identification of consonants involves correctly distinguishing the higher frequency components in a pronounced word. The human sound production and recognition system, the vocal cord and the ear, is less sensitive in the higher frequency area as compared to the lower frequency area. The corruption by noise in the higher frequency area makes the recognition further difficult. It is difficult to comprehend consonants under noisy environment. For example, the difference between word and heard is very small. The identification of consonants involves correctly distinguishing the higher frequency components in a pronounced word. The human sound production and recognition system, the vocal cord and the ear is less sensitive in the higher frequency area as compared to the low frequency area. The corruption by noise in the higher frequency area makes the recognition further.
Yes. So the first that was played had 70% announcement and 30% noise. Female, male. After that, it was 50% announcement and 50% noise. So we set out to look at exactly which words we lost. So first one that we found out was pronounced. That word was lost. So we looked at the frequency spectrum, or that is the frequency content of the word pronounced. We started looking at that, and at the same time we looked at the frequency content of the noise. We found that the noise had a peak at 300 Hertz. We saw that the male announcer pronounced was totally lost. Female announcer's word pronounced is still can be heard even in 50-50 situation. So why? So we went into psychoacoustic model. Psychoacoustic model, sub part of the psychoacoustic model, which says that there are bands of frequencies, 100 Hertz to 200 Hertz, 200 Hertz to 300 Hertz. And there is something called the interband masking as far as frequency is concerned. I'm not talking about loudness, I'm not talking about volume. Inside the frequency of 100 to 200 Hertz, if 150 Hertz is present, it would do masking Masking means mask, you know, it renders particular frequency, you cannot hear, it renders it, you cannot hear it. So a particular frequency, so if 150 hertz, the center of the band is present, then rest of the frequencies will get subdued in that band. So this is one aspect, that is something called intra-band masking, and there is another thing called inter-band masking, that is 150 hertz present would also mask certain frequencies in the other bands. That is one. So we found that 300 hertz was a very predominant frequency, and the female voice had 300 hertz at 1400 in some units as a count, whereas the noise predominant frequency 300 hertz was having a count much less. It was somewhere around 600. A male voice 300 hertz, it also had a peak, the word pronounced had a peak, and that was very low, and therefore the word pronounced has got lost. Second word that we identified, that in the male announcement the word ear, I am the announcer, that's why the way I have pronounced ear is r, that part, and the female announcer pronounced it as ear. So that R part of it, R predominantly has higher frequency contents. So we analyzed it. We found that the male announcer had 1 kilohertz frequency content in ear. Female announcer did not have 1 kilohertz frequency content. The noise was predominantly 300 hertz. So evidently that R part of it came very predominantly, and therefore the word ear of the male announcer could be heard very easily. These were the two things, that is one is a psychoacoustic model and another is the actual frequency analysis. So it's not just the volume, we tend to blame the volume of the PA system very frequently, but it's not just the volume, it is also the frequency contents, and especially the frequency contents of the consonants that make all the difference.